Here we have another derivatives example problem. And in this example problem, we're going to differentiate a function, but we're not going to say which technique that we want to use. So a little bit of a refresher, we have four techniques that we've studied. We have the power rule, we have the product rule, we have the quotient rule, and we have the chain rule. And we can use any of these four to differentiate functions. So for our example problem, we have h of x, which is going to equal 2 divided by 4x plus e to the negative 9x all raised to the 10th power. So the first step is we want to look at our function and determine which differentiation technique that we want to use. So when we look at our function, we see that this is a fraction, and so this means that we're likely going to need to use the quotient rule to differentiate this function. So after selecting the quotient rule, we can go ahead and apply the formula that is given for the quotient rule. So we can split up our f and g terms, where our f term will be the top term, or 2, and the g term will be this bottom term, or 4x plus e to the negative 9x, all raised to the 10th power. So when we take the derivative of f of x, we're going to get 0. And when we take the derivative of g of x, we're going to need to use the chain rule, which is another differentiation technique. And then we'll get 10 multiplied by 4x plus e to the negative 9x to the 9th power, multiplied by 4 minus 9 e to the negative 9x. So after we have our four different terms, our f of x, f prime of x, and our g of x and g prime of x, we can use these terms to plug it into our quotient rule equation. So here we have plugged in our different quotient rule, our different functions into the quotient rule equation. And after a little bit of simplification, we can get it to be negative 20 multiplied by 4x plus e to the negative 9x to the 9th power divided by 4, or multiplied by 4 minus 9 e to the negative 9x, all divided by 4x plus e to the negative 9x to the 20th power. So the big thing here is that we see that our denominator term, 4x plus e to the negative 9x, is the same as one of our numerator terms. And so we can go ahead and put this bottom term up on the top and make the exponent negative. And then we can combine like terms. So here we have our term raised to the 9th power, and here we have our term raised to the negative 20 power. And so we can combine these two terms and add them together to get negative 11. And so that's what we'll do to further simplify this expression and get our solution, which is h prime of x is equal to negative 20 multiplied by 4x plus e to the negative 9x to the negative 11th power multiplied by 4 minus 9 e to the negative 9x.